Good morning, everyone. This is Unit 4, Lesson 14. There's a new EQ, but the whole concept behind functions is going to be the same. So let's read the EQ and the LT. The EQ is, how can we determine and relate the key features of linear functions to real-life numerical relationships? The learning target is, I can use rate of change to determine if a function is a linear function. Alright, so we're going to be looking at tables, and we're going to be talking about rate of change, and we're going to talk about that in the mini lesson, but we're just going to determine if a table is a linear function or if it's a nonlinear function. Alright, so let's take a look at the brain starter. The question is asking, which set of numbers has a pattern, and what is the pattern increasing by? Okay, so I would suggest that you pause the video and you answer this question yourself. But let's take a look at set 1 and set 2. In set 1, if you answer the question yourself, you notice that set 1 is the answer. Why? Because each time you jump from one number to the next number, you're continuously increasing by the same number, and it is increasing by 3. In set 2, we are increasing by 2, and then we get to the number 7. From 7 to 8, this one increases only by 1. So the pattern changes there. And then it goes back to plus 2, plus 2, plus 2. But the pattern does not stay consistent throughout the entire set. So that means that set 2 is wrong, and set 1 is the one that has the same pattern, and it increases by 3. Alright, so this is going to be something that we're going to try and look forward to when we try and take a look at tables. Alright, going ahead to the mini lesson, the two questions that we should be asking ourselves are, what is the rate of change in functions? And what determines if a function is linear or nonlinear? Alright, so to answer the first question, rate of change is how much our y value changes divided by how much our x value changes. If the rate of change is constant throughout the whole table, then the table is linear. So if it keeps increasing by the same number, just like we took a look at the brain starter, that means that the table is linear. That means that the line on a graph would be a straight line going from left to right. If it does not increase by the same number, then the table can be any kind of function. It's just not going by a straight line. Okay, so we want a graph. We want to know if a graph is increasing by a linear or if it's nonlinear. Alright, so let's take a look at these tables, okay? We said that the rate of change is how much our y value changes divided by how much our x value changes. Okay, so going from our first number to the second number, we notice that from 12 to 19, we have to add 7. We have to add 7. So our y value changes by 7, and our x value changes by 1. So we're going to have 7 over 1 equals 7. So far, from our first number to our second number, we have a rate of change of 7. Let's see if it continues with the same number of 7. From 19 to 26, we increase by 7, and the x value also increases by 1. So 7 divided by 1, we get 7. So far, we have 2 7s, which is good, but it has to stay consistent throughout the whole way. 26 plus what number will give you 33? Yup, it's 7. And from 3 to 4, we get plus 1. So again, our y value changes by 7, our x value changes by 1. So therefore, it increases by 7 again. So that means that this table is linear. There's a constant change of 7, and the rate of change is 7, so that means if it stays constant throughout the whole way, this table is linear. So let's take a look at a table that's nonlinear. 9 to 12 increases by 3. 1 to 2 increases by 1. 3 over 1. So from the first number to the second number, the constant, or the rate of change is going to be 3. Let's see if the constant stays the same. From 12 to 17, not 3, that's plus 5. 2 to 3, that's plus 1. 5 over 1, we know that that's 5. Already we see 2 different numbers. So right away we should know this is non-linear. So if we want to try and take a look at the rate of change, 7, 7, 7, which means that it is linear. We see 2 different numbers over here on the right side. We see 3. We see 5. That means that it is all different and it is nonlinear. Now, some of you might be asking the question, why are we using division if we're just seeing 7 divided by 1? And we should know that if we see an increase by 7 on the right side, we should know that the rate of change is going to be 7. That would be a great question. But the left side is not always going to be increasing by 1. And I'm going to show you another table in the model problem. Okay, so let's take a look at this model problem right here. Is this table linear or nonlinear? So remember, we want to try and find the change of y. So the change from our first value to our second value in our y is from -3 to +1, and that gives us +4. And our x values change from -3 to -1. So now we notice that the x change is not just the number 1, it can also be 2. It can be any number. Okay, the table on the left side is not always going to be increasing by 1. So this is why we're choosing division. Okay, so let's see. 4 divided by 2, we know is 2. So right now we have a rate of change of 2 for the first one. Let's take a look at the second one. So from +1 to +9, we see that there's a change of 8 in our y value. And for our x value from -1 to +3, there's a change of 4. 8 divided by 4, we have a rate of change of 2. Okay, so far our table is going to be considered linear because the rate of change is the same. But from 9 to 15, there's a rate of change of 6. And from 3 to 6, there's a change of 3. So 6 divided by 3 is 2 again. So we just have to see if it stays consistent one more time. From 15 to 17, there's a change of 2. From 6 to 7, there's a change of 1. 2 over 1, our rate of change is all the same. Throughout the whole table, there's a rate of change of 2. So that means that this table is linear or nonlinear. You got it. this table is linear, the rate of change stays consistent throughout the whole table. Okay, so remember, we can't just take a look at the right side and say, oh, it increases by 4, so the rate of change is 4. No. We have to divide by how much the y changes. Remember, how much the y changes divided by how much the x changes, and that's going to be your rate of change. For work time, we're going to write down Google Forms. There's only 5 questions. It's multiple choice. All you have to do is determine if it's linear or nonlinear. Remember, these Google Forms impact your grade. And then for closing, it's closing/summary. A lot of you have been giving very vague summaries and closings. I just need you to write down what it is that you learned from today's lesson. Okay, so what resonated with you means, what did you learn? What is today's skill that you need in order to answer to today's question? And if you have any other questions, feel free to go ahead and write those questions down. If you have any questions, this lesson is due on Tuesday night by midnight. Feel free to go ahead and ask any questions to Ms. Grubb or myself. I hope everyone stays safe and has a great day.